I welcome you to the second session of geometry. In this session, we will take a look at some properties of triangles. If you're looking at formulas of areas and perimeters of triangles, then that is covered in the sessions of mensuration. Here we will be specifically covering the properties of triangles. So if ABC is a triangle, and you will notice that we have small a, small b and small c as sides opposite angle A, angle B and angle C. This is a standard nomenclature that we will follow throughout this session. Property 1, the sum of any two sides of a triangle is greater than the third side. So mathematically, what does it become? A plus B is greater than C. So sum of these two sides, A plus B is greater than C. A plus C is greater than B. So we have these two sides and their sum is greater than B. And B plus C is greater than A. Now, effectively speaking, in order to apply this property to any problem, we need not form three equations. In fact, any two equations will suffice. Let us see one question based on this property. Let us say ABC is a triangle such that the length AC is 6 and the length AB is 8. The length BC is not known to us. Now the question is, find the maximum and minimum value of x. So obviously we can apply the property that the sum of any two sides of a triangle is greater than the third side. What we do not know, however, is whether x is less than 8 or x is more than 8. Because if x is less than 8, then the side AB, which is of 8 units, will be the largest side. And if x is greater than 8, then side BC, which is x units, will be the largest side. So let us apply case 1 when x is greater than 8. So when x is greater than 8, the sum of the other two sides, 6 plus 8, must be greater than 8. So which means 14 must be greater than x or x must be less than 14. This is a simple inequality. Case 2, when x is less than 8, when x is less than 8, we get 6 plus x is greater than 8 and therefore x must be greater than 2. So we see that x has to be greater than 2 and x has to be less than 14, which means 2 is the minimum value of x, which will approach 2, and 14 is the maximum value possible of x. In fact, the maximum value will approach 14 but will not be exactly equal to 14. The next property is the property of exterior angle of a triangle. Now the first thing that I need to tell you is exterior angle is formed by extending any one of the sides of a triangle. For example, here we extend CB to get the exterior angle E. And if R1 and R2 are two remote interior angles, so these are angles which are farther away from this exterior angle E. So if E is an exterior angle, R1 and R2 are two remote interior angles. We have the property exterior angle is equal to the sum of two remote interior angles. E is equal to R1 plus R2. Let us look at some questions based on this particular property. We have a triangle ABE and AEC as shown in the figure, and we are required to find the value of x here. And given that BE is equal to AE is equal to EC and angle EAC is 40 degrees, then what is the value of x? That is what we are required to find. Now let us mark out all the equal sides on the triangle. So we have BE, AE and EC as equal. Next, we all know that angles opposite equal sides in a triangle must be equal. This is a simple property which we have studied before. In triangle AEC, this is a triangle AEC. Angle AEC plus angle EAC plus angle ECA is equal to 180 degrees. Because sum of angles of a triangle is 180 degrees. Now we already have the value of EAC. So we put the value of angle EAC and angle ECA as 40 degrees. Now this angle EAC and this angle ECA must be equal because they are angles opposite equal sides. Once we get these values and substitute the value of EAC and angle ECA, we get the value of angle AEC as 180 minus 40 because both ECA and EAC are 40 degrees. So next, on solving the equation, we get the angle AEC is equal to 100 degrees. So angle AEC, this angle is 100 degrees. Now you would notice that this angle is exterior to angle ABE, triangle ABE. And in triangle ABE, angle X degrees must be equal to angle BAE. So ABE angle must be equal to EAB angle. So we solve it further. AEC is equal to angle ABE plus angle BAE because exterior angle is equal to sum of two remote interior angles. We apply the same property once again. 100 is equal to 2x. Why 2x? Because both ABE and angle BAE are equal. And on solving this, we get the value of x as 50 degrees. Next, in the triangle given below, calculate the value of x if AB is equal to BC, is equal to CD, is equal to DE, is equal to EF, if angle BAC is 20 degrees. Now we had a similar question in CAT. In fact, the question of CAT did not give the value 20. And this question appeared in CAT 1999, a very similar question. Let us see how to approach such a question. But first of all, let us mark out all the equal sides. So we have AB, BC, CD, DE and EF as equal. Now once we have these sides as equal, let us apply the basic property of triangle. The sum of three angles of a triangle is equal to 180 degrees and exterior angle is equal to sum of two remote interior angles. These are the only two properties that are applicable in solving this question. First and foremost, if you look at triangle ABC, AB and BC are equal. Therefore, angle BAC must be equal to angle BCA. So, angle BAC must be equal to angle BCA, that is equal to 20 degrees. So, we have angle BCA marked out there as 20 degrees. Now, if you look at triangle ABC, CBD is an exterior angle to this triangle because it is formed by extending AB, and therefore angle CBD must be equal to angle BAC plus angle BCA, which is equal to 40 degrees because both BAC and BCA are 20 degrees. Now we have angle CBD as 40 degrees. Now angle CBD must be equal to angle BDC. Why? Because in triangle BCD, side BC is equal to side CD. Therefore, this angle must be 40 degrees. So there we mark it out as 40 degrees. Now look at triangle ACD. If you look at triangle ACD now, triangle ACD, we have angle DCE as exterior angle, this angle DCE as exterior angle, and which must be equal to angle A of triangle ADC plus angle D of triangle ADC, which is equal to 40 plus 20, that is equal to 60. So angle DCE, the exterior angle to triangle ACD, must be equal to angle CAD plus angle ADC, and therefore this must be equal to 60 degrees because CAD is given as 20 degrees and we calculated angle ADC as 40 degrees. So we get this angle DCE as 60 degrees as marked out there. Now angle DCE must be equal to angle DEC because in triangle DCE the sides DC and DE are equal, and therefore angle DEC is 60 degrees as we can see marked out there. Now we have the triangle ADE. In triangle ADE, angle EDF is the exterior angle here, and this must be equal to the sum of angle A, that is 20 degrees, that is DAE, plus angle DEA, which is 60 degrees. So let us see that. Angle EDF is equal to angle DAE plus angle DEA. By the same property, exterior angle is equal to sum of two remote interior angles. This is equal to 80 degrees. And therefore in triangle EDF, because DE and EF are equal, angle EDF is equal to angle EFD, which is equal to 80 degrees. And this is your answer. So X is equal to 80 degrees. So with this, we have come to an end of the first session of properties of triangles. In case you have any feedback or any query, please feel free to contact us on studentservices@pfindia.com. Thank you.